Hello, my name is Shruti Vinod and this is Lab Report 2 for Physics 2211. The goal of this experiment is to show the concepts of gravity and drag affecting falling objects in their position. The initial conditions of our system are that the initial velocity in every direction is 0, and the force applied by the hand holding the toy object and the object's weight are equal and opposite, according to Newton's second law. So once the toy is dropped, our unit vector position becomes approximately 0, -1, 0. So these are the equations that are necessary for this lab. So F net is equal to the derivative of momentum over time, and we are going to use the velocity update formula along with the position update formula, and the force of gravity is equal to the gravitational constant times the mass of the first object times the mass of the second object over the radius or the distance between both the objects times r hat. And we're also going to use the F drag, force of drag, like drag force formula. As you can see in this certain video, this toy is dropped from a certain height, and this is the data that is collected by Tracker. Here we're understanding the code, and this is a code for only gravity, and here we have our ball's mass, our ball's position, the g is equal to 9.8 meters per second squared, j hat, which is vector of 0, 1, 0, and b is equal to 0 here, our constant is equal to 0. And we also have how to calculate the net force, which is negative mass of the toy or ball times g times j hat. And we also have the velocity and position update formulas to find the object's velocity and position. So comparing our results here, we can see that it is pretty deviated. So the one that is by the tracker goes much lesser than the one that is predicted by the coding. Now we are going to analyze the code with the drag force, and the main thing that changes here is our b value, and through solving we find that the b value here is 0.0085, and we also change how to calculate the net force, which is now we have w, which is the same as the previous equation, and we also have fd, which is f drag, and we have b times the magnitude of the velocity of the ball times the magnitude of the velocity of the ball times j hat. Now comparing all three, tracker, gravity, and gravity plus drag, we see that again the tracker and the gravity completely deviate, gravity only, so they completely deviate, but we see that the tracker and the predicted for gravity plus drag are pretty in line, so we can see how much of an effect giving b a value makes. So entering a discussion of the results, we can see that the gravity-only model does not really match the data very long, and the computational model gravity-only was just 63% accurate to the true data, whereas the gravity plus drag model matches the data much better, and it was 99.85% accurate to the true data. So what if, and what does it mean? What if our downwards was consistent y-axis, negative y-axis instead of positive y-axis? All our values would be negative instead of positive. What if drag was not a factor affecting the toy? Then the computational model using only gravity would be much more accurate. What if the object was thrown down instead of dropped? Then the cup would reach terminal velocity quicker, and there'd be less of an exponential increase in position. And finally, what if something like a ball was dropped instead of this toy? Then the drag would have been much less of a factor, and the ball would have reached terminal velocity much quicker. Thank you very much.